The next topic is sinusoidal input given to pure resistive circuit. So here let us consider a circuit which is connected to an AC supply and consisting of a pure resistor. Let the voltage across the supply is taken as Vm sin omega t and let the voltage drop across the resistor be Vr. So according to KVL, the sum of voltage rises, that is Vm sin omega t is equal to sum of voltage drops, that is the voltage drop across the resistor, which is taken as I into R. So from this equation we can write I is equal to Vm by R sin omega t. So here I am taking Vm by R is equal to Im. Therefore we can write the equation as I is equal to Im sin omega t. So when we compare the voltage and current equations, the voltage equation is Vm sin omega t, whereas the current is represented as Im sin omega t. These two equations can be represented in the form of a waveform. Therefore, Vm sin omega t, here the reference angle is taken as 0. Therefore, the waveform starts from 0. Im sin omega t, here also the angle is taken as 0. Therefore, it is represented as Im sin omega t. Here the magnitude is little bit less than that of your voltage. From these two waveforms, we can conclude that the current is in phase with voltage, which can be represented as, if this is a phasor which represents I, V is in phase with I, therefore it is represented on the same line, implies the angle between the voltage and current is equal to 0. If we want to calculate the value of power, the instantaneous power is given by the product of instantaneous values of voltage and current. Therefore, Pt is equal to Vt into It, where Vt is equal to Vm sin omega t and It is equal to Im sin omega t. From these two equations, we can write this as Vm Im is into sin square omega t, which is equal to Vm Im sin square theta is nothing but 1 minus cos 2 theta by 2. Therefore, Pt is equal to Vm Im 1 minus cos 2 omega 2 by t. If when we want to calculate the average power is given as P average is equal to 1 by t integral 0 to t pt into dt. So here the time period for an average value is taken as pi. Therefore 1 by pi integral 0 to pi Vm Im 1 minus cos 2 omega t by 2 into d omega t. If we bring this Vm Im outside, Vm Im by 2 pi integration of constant is equal to omega t within the limit 0 to pi minus integration of cos 2 theta is equal to sin 2 theta by 2 within the limit 0 to pi. Therefore, we can write this equation as Vm Im by 2 pi, substituting the limits upper limit minus lower limit. Therefore, pi minus 0 minus, I am bringing this 1 by 2 outside, 1 by 2 sin 2 pi minus sin 0. So, sin 180 is 0, sin 0 is also equal to 0. Therefore, this term becomes 0. Therefore, we can write the equation as Vm Im by 2 pi into pi, which is equal to Vm Im by 2. 2 can be represented as root 2 into root 2. Therefore, Vm by root 2 into Im by root 2, which can be taken as Vrms into Irms. Therefore, the power P is equal to Vrms into Irms. Therefore, the average power across a pure resistor is equal to the product of RMS values of voltage and current. Thank you.